same number of points above and below the line, and trying to pick our best equation from there. Then we got into the ones where we had to write our own equation, and there's options for doing that, but the smartest option is just to use our resources. We have a graphing calculator. It finds the line for us. You have that on the EOC, so that's your best bet. If you are given a set of data, okay, we're just going to treat this is like our x and this is our y. If we want our equation to write the line for us, we are going to enter this data. The first one's go into L1, second one's go into L2. You have to put them in order. You have to make sure you type them exactly. Okay, I'll get your binder and calculator, please. So, on your calculators, remember, do not delete your list. It kind of messes everything up. You need to go into Stat, and then we are going to first edit. So Stat number 1. Okay, there is data entered in here, and I told you you don't want to delete it out, so how do we get rid of this?
Clear and enter.
Yes. You use the up arrow until you have the name of the list highlighted, so mine says L2. And if I hit clear enter, it wipes out all of those points, but it doesn't take out my list. If you use delete, that entire column disappears, and then we have to change a bunch of other settings on your calculator to get it to work from there. I need to do the same thing for the first list. So I'm going to go over to L1, clear, enter. Now, you have to type in your points. These are like ordered pairs, so they have to go in order. So in my L1, I'm going to put all my X's. So I have my 75, 92. Everybody's doing this with me. Everybody should have a calculator in their hand right now, typing these points in. If you have trouble getting your list cleared or anything, please ask. When you get to the end, these lists should be the same size because we essentially put in ordered pairs. All right. Does everyone have your data entered? So now we go back to Stat. Okay, but this time we don't want to edit anything, we want to calculate something. So you use your arrow until calculate is highlighted, and we want number 4. It tells us linear regression, so you can push a 4. What do we do on this slide? Do you remember?
Enter.
Just enter to get through everything, and then it pops up with this. Y equals AX plus B. Okay. So we're used to y equals mx plus b. The only difference is it says a instead of m. The exact same thing. So that is our slope. So if we look at this one, my A, 1.97996. So we just usually round to a couple decimal places. So let's round to 1.98. X plus B, our y-intercept, so 7.966, so that would be 7.97. Did everybody get that equation? So now part B, we are going to use the equation. So estimate the number of suitcases on a flight carrying 250 people. So if I look back at my table, 250 people, that's my passengers. That was my X. So I'm telling you X is 250. So I'm going to plug that in. 1.98 times 250 is 7.97. You guys are free to plug that entire thing in the calculator at once. There's nothing that says you can't. You can type in 1.98 times 250 plus 7.97 and do it in one step. And my calculator tells me 502.97. Did everybody get that? Now, if I'm trying to check if this is reasonable, what does Y represent? Suitcases. Can you have 0.97 of a suitcase? No, you either have a suitcase or you don't. So what would I round this to for my final answer? So we would have 503 suitcases. Just because we know it wouldn't be reasonable to have a partial in this case. So we could round our answer to give the most accurate thing possible. Number 3, why don't you guys try that one first? So try to enter your data and get your line. My X's were years, but when you're putting in 2,000 something, that's giving us a pretty big value. Okay, so that's why our equation is so outlandish here. A lot of times what you're going to be told to do on these types of problems is change your X's to basically be how many years have passed. If we look at this problem, it says the data in the table shows the number of graduating seniors since 2012. So 2012 is like our starting point. So I could think of that as year 0. 2013 is how many years after 2012? That should be an easy question. 1. 2014 would be 2. 2015 would be 3. 2016 is 4. 2017 is 5. So if we're talking about years since something, make that first year, year 0. And then increase them from there. So we have our X, we have our Y. If we alter that, so if we go back and go into Stat, Edit, I'm going to change my first list to 0, 1, 2, 3, 4, 5. Okay, my Y's didn't change, but I changed that first list. Now if I look at my equation, does that give us better numbers anyway? My B is now in the hundreds instead of the thousands, so I think that's a lot better. So my equation, Y equals A, so 9.17, plus B, 338.24. Okay, does that mean you couldn't do it the original way with just those numbers? No, you'll still get an equation, you just have to know how to use it. And if you stuck with your original equation, when it got to 2025, that's what you'd plug in for your X. If I'm doing this method, X is my years since 2012. So 2025 is how many years since 2012? 13, you just subtract them. So if I'm doing this, I plug 13 into my equation. type all of that in on our calculator at once. And I get 457.45. Now what does that number represent? Why was the graduates? Okay, in your senior class, can you have a 0.45 graduating? No. What would I round this to? Would it go? We'll just go ahead and follow the regular rounding rule. So if it's 0.5 or higher, we'll round up. If it's less than 0.5, we'll just round to that whole number. So this isn't enough to round up, so we'll just keep it at 457 seniors. Or graduates, however you want to label it. So we have 457 graduating that year. Let's try another one with those years. Okay. So this tells us the data in the table shows the Olympic 500 meter gold medal speed skating times. So if I look at my X's are all years. So if we want more reasonable numbers, what could I make my 1980? That could be my year 0, if I just wanted to start there. The 1984 would be, how many years since 1980? I didn't go up by once this time. So this would be 4 years. 1988 would be 1992, 94, and I didn't keep following the same pattern, did I? 1994, I only went up 2 that time. 14 kind of tricked us. We're in a weird point there. 1998 minus 1980 gives us 18. So all of them were going up by 4 except that one. So we kind of have to watch. Let's enter those. Stat, edit, clear what's there. Stat, calculate, linear regression, my A is negative 2.29. My y-intercept 430.56. Then answering the question, estimate the 500 meter time for the 2020 Olympics. If I started in 1980, and that was year 0, 2020 is how many years later? 40. Just subtract them. So I'm going to plug in a 40. Type that all into your calculator at once. We get 338.9 looking back here, my y was a time. Can you have a decimal when you're talking about time?
Yeah.
Yeah, if you're looking at a stopwatch, we most certainly can. So I don't have to round this time. That answer would make sense. And I knew it was in seconds because my table told me the time was in seconds. All right, I want you guys to jump down and try problem 6 for me. Get your, okay, so you get y equals ax plus b, here a, 0.137, so we round that to 0.14x. B is a negative, so we should say minus 0.25. Did you guys get that equation? Alright, Sam has the same height as the people in this group. He has a BMI of 25, estimated his age. When I look at this, or sorry, his weight. My weight was my x, my BMI was the y. So did I give you x or y this time? I gave you the y. So our y is 25. So in my equation, I'm plugging 25 in for the y. Okay, so we solve this equation, we add the 0.25. We get 25.25. Divide by 0.14. And we get 180.357. So if I want to keep two decimal places, I look. Since 7 is bigger than 5, I round this up. So 180.36. X was my weight, so this would be in pounds. Can you have a decimal when you're talking about pounds?
Yeah.
Yeah. So we don't have to worry about that. Any questions on this one? Last problem of the day. This time, instead of giving you a table, I gave you the graph. So, we have two options. If I look, first of all, my x's are again years. It really doesn't matter. We can change these to like our 0 and so forth, or we can keep them as they are. Do you guys have a preference? Do you like dealing with the smaller numbers? Okay, if you want to, we can change them. 1990 would be then our beginning, so that would be year 0. 94 is 4 years later. 98 is 8 years later. 2002 would be 12 years. 2006, 16, 2010 is 20. You don't have to. If you want to keep those others, you'll get an equation. It will work. It's not a big deal. When I want to get my line of best fit, though, I'm going to actually just have to read these points. So I'm going to clear out everything that's in here. Okay, so then if I look, this first point, my year is 0, my y was 4. So I'm going to put a 0 for the first one, my y is 4. So it's like a point. If you want to, you can write them out in a table first, if that's a little bit easier. So year was 4. The next one, okay, this would be when x was 2. This y between 4 and 5 would be 4.5. Okay, this would be when my x was 6. That's between 4.5 and 5, so 4.75. So I'm kind of reading my table, or my chart here to get my points. You don't have to write this out first. You could just be putting these in the calculator. Either one is fine, whatever makes sense to you. So I got the first 3. This one is year 8. My height is 5. Year 10. My height is 5. Year 12, I'm in between 5 and 6, so 5.5. Year 14, we're at 6. 16, we're at 7. 18, we're at 7. And 20, we're at 7.5. So I gave you all the same things, it was just in a different format. I gave you the picture instead of the table. Well, once you get your table, you can put those in unless you were doing that the entire time. And then I can get my equation. So I have y equals 0.17x plus y-intercept 3.7. And then I want the year in which the tuition will reach 10,000. So if I look at my graph, 10,000 was my y. So I'm telling you y is 10,000. So we're plugging that in for the y value. Factor 3.79. Oh, we do have a mistake here. I don't want to put in 10,000. Because my tuition is already in thousands, so it's 10,000. The label is already thousands, so all we have to do is plug in the 10. Factor 3.79. Divided by 0.17. I get my x to be 36.5, or if you rounded, that would take about 37 years. Depending on how you set it up, if you hadn't used like the zeros, your answer would have been the actual year. So if it's been 37 years, another way to think about it, if you started in 1990 and you add 37 years to that, that would be during the year 2027. So if you hadn't changed your x's, if you had just used like the 94, 98, 102, or 02 and all those, you would have got 2027. All right, yesterday I gave you that handout. I told you to do the front page, so hopefully you did. If you did that, you only have a few problems left. But you have the rest of class right now to work on this. You